Have you ever wondered how your bank spots a tiny, fraudulent charge among literally millions of transactions? It's not some person staring at a screen all day. Nope. It's a digital detective, and it's powered by machine learning. So, let's dive into how AI solves this massive real-world problem of credit card fraud. To really wrap your head around the scale of this, let's start with a question. Imagine you're the analyst. You've got a list of over 284,000 transactions in front of you. Somewhere in that massive pile of data, a thief is at work. How on earth do you find them? I mean, it seems completely impossible, right? Well, believe it or not, the challenge is even bigger than you think, because the number of fraudulent transactions in that entire dataset is just this, 0.02%. That's right. Out of hundreds of thousands of purchases, only the tiniest fraction are actually fraud. And that right there is the heart of the problem. We are looking for a very small needle in an absolutely enormous haystack.
So this whole needle in a haystack thing creates some very specific headaches for any system that's trying to automate fraud detection. Here's the deal. We're up against three main challenges. First, the data is what we call imbalanced. Almost everything is normal, and fraud is incredibly rare. Second, we need really high precision. That just means we can't be constantly flagging your legitimate grocery run as fraud and blocking your card. That would be super annoying. And third, we also need high recall, which means we have to catch as many of the actual bad guys as we possibly can. It's a really tough balancing act.
So how do you even begin to tackle this? Well, you train a digital detective. You build an AI model specifically for this hunt.
Now, the specific tool for this job is called a random forest classifier. Sounds complicated, right? But don't worry. The best way to think about it is like a whole team of detectives working a case. Each detective inside the AI looks at the evidence, the transaction data, and forms its own opinion. Then they all get together and vote to reach a final verdict. Is it fraud or is it normal?
But, before our detective team can hit the streets, we've got to prep the evidence. First, we isolate the clues. These are the 30 different data points about a transaction from the final outcome. Then, we split up all our case files. We use 80% of them to train our model, and we hold back the other 20% to test it later on. Finally, it's time to study up. The model goes through that huge training set and starts to learn the subtle patterns of what fraudulent activity actually looks like.
All right, so once our detective is all trained up, it's time to start the real investigation, looking for those hidden patterns that separate legitimate purchases from criminal ones.
And it finds a major clue almost immediately. Just look at this. On the left, you've got the average amount for a normal, everyday transaction. But on the right, that's the average for a fraudulent one. The difference is, wow, it's pretty striking, isn't it?
So what does this tell us? Well, it points to a really key insight. Now, of course, not every big purchase is fraud and not every small one is legit, but there is a clear and powerful pattern here that our digital detective can latch onto.
Okay, so our detective has been trained, it's found some pretty solid clues. But how did it actually do when we let it loose on the test data it had never seen before? It's time to check the scorecard.
Whoa, okay, at first glance, these numbers look incredible, right? I mean, an accuracy of 99.96%? That seems basically perfect. But remember that needle in a haystack problem? If a model just guessed normal every single time, it would still be 99.98% accurate. So accuracy by itself can be really misleading here.
So let's kind of push that big flashy number aside and focus on the two metrics that really tell the story of our detective's performance: precision and recall.
And this right here, this is the critical balancing act. Our precision is almost 99%. That's fantastic. It means when our model points a finger and says, that's fraud, it's right almost every single time. That means very few false alarms, which keeps customers happy. But then you look at recall, it's about 80%. And what that means is, for all the fraudulent crimes that actually happened, our detective managed to catch about 4 out of every 5.
This chart really puts that recall number into perspective. For every 100 actual fraudulent transactions that happened, our system successfully caught about 80 of them, which is good. But that also means that 20 of them slipped right through the cracks. And this is the constant battle in fraud detection. Do you tune your model to catch more bad guys, even if it means you get more false alarms for innocent customers?
So let's pull all of this together. As we wrap up this look inside our digital detective agency, what are the big takeaways you should remember?
First off, fraud is super rare, and that's exactly what makes it so hard to find automatically.
Second, these AI detectives can be trained to see patterns in data that a human could just never spot. Third, sometimes simple clues like the transaction amount are incredibly powerful. And maybe most importantly, success isn't just one number. It's this delicate balance between catching the criminals and not bothering innocent people. And of course, there's always room to get better, maybe by using special techniques to balance the data to help our detective catch that last 20%.
And that leaves us with one final big question to think about. In a world where you'll never have perfect data, what is the perfect balance? Is it better to let one thief get away to make sure 1,000 innocent people aren't hassled? Or is it worth a few false alarms to make absolutely sure you catch every single bad guy? The math gives us the tools, sure, but the answer to that question, well, that's something we all have to decide.